The Blacktop Speedway is a supplier of automotive parts. Included in stock are 6 speedometers that are correctly calibrated and 2 that are not. 3 speedometers are randomly selected without replacement. Let the random variable x represent the number that are not correctly calibrated. Complete the probability distribution table. Report probabilities accurate to 4 decimal places. Find the mean of this probability distribution. Appropriate rounding rules apply. All right, so far they've already filled in the x values for us, so we'll go ahead and use that. Okay. Then we need to calculate the probabilities of each possible value of x. All right, so now to do this, we need to consider the problem again. It says that included in stock are 6 speedometers that are correctly calibrated. Okay, so there are correctly calibrated 6 of them and 2 that are not. So wrong, we'll just say wrong. So we can use C for correct and W for wrong. So we have 2 of those. Okay, so that means we have a total N of 8. Okay, 3 speedometers are randomly selected without replacement. Okay, so let's think of this as our R. We're going to select 3. Okay, N is the total that we're selecting from. Total items. Okay. All right, so we've got that organized. We're also doing this without replacement. Without replacement, or repetitions are not allowed. Okay. Let the random variable x represent the number. Okay, this is important, so let's not kind of glaze over what x represents. X represents the number that are not correctly calibrated. Okay, so after we select, x is the number not correct, or the number of wrong. Okay, and complete the probability distribution. Okay, so then the number of the probability of 0, the probability of 0 is the probability of all 3 that we select are correct, or you could just say that 0 are incorrect, which is why x is equal to 0. Okay, so we can write it both ways. None wrong. Okay, no W's. No W's. Or another way of saying that is all correct. Okay, so how are we going to figure this out? What is the probability that none are wrong? Well, on the first selection, how many wrong are available? There's 2, right? And how many are correct? Because I want this to be one that's not wrong. So I should do 6 out of 8 for the first selection times, on the second selection, 5 out of 7. So 5 correct ones will be left out of a total of 7. And finally, on the third selection, 4 out of 6. Right, so that's how we're going to figure out the probabilities for each of these. That's how you would do it by hand. Okay, so I did 6 divided by 8 times 5 divided by 7 times 4 divided by 6. On the next one, the probability of only one being correct, or excuse me, only one wrong, right, is another way of saying that is the probability of one wrong and two correct, right? So to do this, I'm going to do the probability of the first one being wrong is 2 out of 8 times the probability that the second one is correct. There's 6 correct, right? So 6 divided by only 7 remaining after I took out a wrong one, then times 5 correct left out of a remaining 6. And so we continue in this way to get all these answers. So then the probability that 2 are wrong, another way of saying that, the probability that 1 is wrong and 2 are correct. I meant to say it the other way around. 2 wrong and 1 correct. Okay, so that's equal to wrong 2 out of 8 on the first, and then I have 1 wrong left out of 7. Then I have 6 correct left out of 6 remaining. And finally, the probability that 3 are wrong. So that's the probability of wrong, wrong, wrong. Okay, so how do we calculate that? The probability of the first one being wrong is 2 out of 8. The probability of the second one being wrong is 1 out of 7. And then the probability that the third one selected is wrong is actually 0 out of 6, or just 0. All right, so now let's see what happens when we enter these in. Didn't like that, but the rounding rule is 4 decimal places. So let's see if that makes a difference. No, doesn't like that. Oh, I know why. Because I didn't consider the fact that I could have 1 wrong. I could have wrong, correct, correct, wrong, correct, correct. I could have correct, wrong, correct, or correct, correct, wrong. So there's actually 3. I need to multiply this probability times 3. Which is not a probability. So what's going on with that? Hold on. Gotta think. Hold on. Oh, I just realized I was multiplying the wrong probability. So that was for the probability of 1. So that's this one that needs to be multiplied times 3. And then we get the right probability, which goes here. Okay, now the next one, how many ways can I get 2 wrong? Well, I had 2 wrong and 1 correct. So the correct one can be the first, the second, or the third. So again, I have 3 possible ways that this could happen. So I'm going to multiply this times 3 because it's like adding it to itself 3 times. Multiplying is repeated addition. So we're going to add that in. Okay. And then finally, the last one should be 0. Okay. Now to show you another way of getting this is if you think of this as a binomial distribution, you might try to use the binomial distribution, but you would not be able to because it is without replacement. So if that was on your mind of thinking of these as, you know, pass, fail, so there's only 2 possible outcomes per trial, yes, that's true. But remember with binomial, the binomial probability distribution only works when you have the same probability every single time you do a trial. So it wouldn't have worked anyways. Now to get the mean, we're going to do a working column to use um, the formula for calculating the mean from probability distribution. Okay, the mean is mu equals the sum of the products of each individual x value times the probability of x. Okay, so we are going to have a working column where we do x times p of x for each row. So I'm just going to set that up as a calculation on the first row and then relatively copy that down. All right, so now that I have that, I just need for the mean the sum of that third column. So I get 0.75. Okay, now it didn't like that. It wants 0.8 because I did not pay attention to the directions which say to use the appropriate rounding rule. The round off rule for measures of center and measures of variation are always, if there's no other directions given, and since they've left it to the rounding rules, the rounding rule for measures of center such as the mean and variation like standard deviation, variance, all those kinds of measurements is one place more than the original x values. So one place more here, there's nothing after the decimal on any of these. So I would want to round to one place after the decimal. And so that's why the correct answer is 0.8.